Hello everybody, Littlefield here. Today we're going to be talking about triangle inequalities. So what you're going to need for this video is your composition notebook, the foldable that I gave you, a pen or pencil, and if you want a calculator, you can have a calculator, but if you're good at mental math, then you don't need one. With that, let's get started. So we have to think about what we already know about triangles before we talk about triangle inequalities. So we already know that triangles have three sides and three angles. We also already know that the interior angle theorem says that all the angles add up to 180 degrees, all the interior angles, that is. And then we know that equilateral triangles have equal sides and equal angles, which means that all the angles are 60 degrees. And we even know isosceles triangles have two equal sides and two equal angles. And we also know scalene triangles, and there's lots of different ways to classify by just the angle. We have right angles, acute angles, obtuse angles. We have so many things. So at this point, you're probably like, isn't that everything we can learn about triangles? Isn't that all? And the answer is no, there's more. There's always more. So we're going to be talking about inequalities in regards to triangles' relationships with their angles and their sides. So under our first flap, the flap in your foldable says, is it a triangle? So we're going in that first flap. We have to determine if the following side lengths form a triangle, or in these three examples. Before we dive right into the example, there's a little prior knowledge that we need to know. We want to ask ourselves, can any three side lengths make a triangle? So if I picked random three numbers out of the air, would those three things, are they able to form a triangle? Would all those lengths add up to meet at three endpoints or three vertices? And the answer is no. In order for a triangle to be formed, the two smallest sides must add together to be bigger than that third side. Okay, so if we look at number one, our two smallest sides are 8 and 17. They're smaller than 24. So we're saying, is 8 plus 17, is that value greater than 24? 8 plus 17 is 25, which is indeed greater than 24. So for our first example, yes, those three side lengths form a triangle. On number two, we have 3, 3, and 7. Our two smallest side lengths are 3 and 3, so we're asking ourselves, is 3 plus 3 greater than 7? And 3 plus 3 is 6, which is not greater than 7, it is less than 7. So our answer would be no. Those three side lengths do not form a triangle. And then in number 3, in our example, our two smallest sides are 7 and 35. Our largest side is 41. So we're saying 37 or 35 plus 7, excuse me, is that greater than 41? Well, 35 plus 7 is 42, which is greater than 41 by just 1. So yes, those three side lengths do form a triangle. Make sure that you write down the red little phrase, the two small sides must add to be bigger than the third side, somewhere. Whether you write it down in your foldable, on the inside of that flap, or the outside of that flap, or somewhere in your notebook around that foldable. That's key information for us to know, okay? So now that we know that the two smallest sides have to add together to make the third side of a triangle, we can identify if three given side lengths are a triangle, and we can also find the range at which we need a third length from two lengths in a triangle. So given the two sides of a triangle, we need to set up an inequality to show the range of possible lengths for that third side. So right now they gave me, my triangle has two side lengths, 3 centimeters and 11 centimeters, and we need to figure out what possible side lengths that third side could be. Well, right now we have two options that can happen for us. The longest side could be 11 centimeters, or there's a side that's longer and is the longest side that we don't know. So we need to set up those two inequalities. So if we say that 11 is the longest side, remember the two smaller sides have to add to be bigger than that. So we're saying the side that measures 3 centimeters plus the side we don't know has to be greater than 11. Okay, so we're setting up that inequality, and then we're saying there is a possibility though that the third side could be the longest side. So if that's the case, we would say x is less than 3 plus 11 because we want the two smaller sides to be greater than that third side. So if we solve these inequalities, so these are the two inequalities that we're going to set up, and then we solve them, and now we have to, once we solve them separately, then we'll have to put them into a compound inequality. So on this left inequality, subtract 3 from both sides to get x alone. 11 minus 3 is 8. So x can be greater than 8, or how we read that from left to right is 8 is less than x, or x is greater than 8. And then on our right inequality, we have x is less than 14. So we're saying that the range for this third side to exist in has to be less than 14, or less x is greater than 8, or the side length can't go less than 8, right? So this would be our answer, that x is between, or the third possible side length is between the values of 8 and 14. So let's look at example 5 and 6. We're going to set up these two inequalities for all of them. So there's always going to be two possibilities for that third side. It is either the longest side or it's one of the shorter sides, okay? So in this example, our largest side could be 31, or our largest side could be x. So we're saying 31 is less than 28, because that was my other side length, plus x. That's my one inequality. And then my other inequality is that x is less than the two smaller sides, which would be 28 plus 31. So subtract 28 from both sides. We get 3 is less than x for one possibility, and then we have x is less than 59 for the other possibility. So my compound inequality would be then that x is between the values of 3 and 59. And how we would write that is 3 is less than x, less than 59. And for our last example, we're saying 24 could be the largest side, or it may not be. So we're going to say 24 is less than 7 plus x, or x could be the largest side, so we'd say x is less than 24 plus 7. So subtract 7 from both sides, we get 14 is less than x, and then we have 24 plus 7, which is 31, so we have x is less than 31. So if we merge those two into a compound inequality, we're going to get x is between 14 and 31. There are some more relationships between the angles and the sides. So the smallest angle will always be opposite the shortest side, and the largest angle will always be opposite the longest side. So if we look at this picture, we have triangle ABC, and we have the three side lengths, 17 meters, 20 meters, and 24 meters. So the shortest side is AB, or the one with 17 meters, and we're saying that angle across from it, or angle C, is the shortest. And so if we're ordering the angles from least to greatest, we start with angle C, and then our next largest side is 20, so the angle across from that is angle A, and then our largest side is 24, and the angle across from that is angle B. So if we order the angles from least to greatest, we're going from angle C to angle A to angle B, because we went from the shortest side to the longest side and the angles that were opposite of those sides, okay? And when we order sides, it's the same thing, but now just the reverse process. So we're saying that the shortest side is going to always be across from the smallest angle, and the longest side is always going to be across from the largest angle. So in this picture, they gave me triangle DEF, and we want to order the sides from greatest to least. We need one more piece of information from our triangle, though. We know that angle E measures 59 degrees and angle F measures 53 degrees. So that means that if we use the interior angle sum theorem, or if we take 180 minus 59 minus 53, we get angle D to be 68 degrees. So if we're ordering the sides from greatest to least, we want to order them largest to smallest, meaning we need to find our largest side length and the angle that's largest across from that to figure it out. So our largest angle is D, and the side across from that is EF. And then from there, we have angle E, and the side across from that is DF, and then our smallest angle is angle F, and the side across from that is DE. So if we order our sides, we should have side EF, then DF, and then DE. So that's ordering from greatest to least. Let's look at a couple more examples. If you want to write these down in your notebook, you can, but it's not necessary, just in case you wanted to see some more. Listen on. So according to this picture, we have triangle ABC here with 3 given side lengths. Which angle would be the largest and which would be the smallest? Well, the angle that would be the largest would be the one across from the largest side. My largest side is AC because that's measuring 7, which is larger than 6 and 5. And so the angle across from it is angle B. And then my smallest side is BC, which has a measure of 5 units, and the angle across from that is A. So my largest angle in this picture would be angle B, and my smallest angle would be angle A. If we look at one more example, we're ordering the sides from smallest to greatest like we did in our foldable. So we're going to start with the side across from our smallest angle, so YZ, and then, oh, excuse me, wow, 35 is smaller than 40. So we're going to start with the side across from that angle, which is XY, and then we go to YZ because 40 is the next largest angle, and the side across from that is YZ. And then the side across from 105 is XZ, so we should be going from XY to YZ, and then XZ, those 3 side lengths in order from smallest to greatest. I want to thank everybody for taking such good notes, and I shall see you soon.